that how the battery maintaining constant potential difference. Right? So here, when the battery terminals are free, it was not connected to any conductor or in an open circuit. What happens? Simply, that electrolyte chemical reaction will force the positive charges and the negative charges to move in opposite directions. This depending on the electrolyte nature, the chemical will decide the electrons and positive charges to move in opposite directions. So that charges are accumulating the metal plates. Then only that accumulation of charges make the metal plates as anode and the cathode. So this process will go on up to accumulation of charges equal amount on the metal plates. So here in this, two types of forces will act, and the two types of forces will become equal in magnitude and opposite in direction. So Fe is equal to Fc, or Fc is equal to Fe. Then that when the charges accumulation sufficiently charged, then that stops. So this is actually what you are having the new battery when you purchase it from the shop, right? Then if once it is connected to the conductor, what happens? Simply electrons has free charges. Sorry, that conductor has free charges. They are electrons. So here near the positive terminal of the battery, that attraction will take place between conductor and the metallic plate. So here positive charges, these positive charges will attract the negative charge. So electron starts moving into the battery. Then here the chemical force will never accept that accumulation of negative charge on the positive plate. So this will remove that chemical force to move towards the negative terminal of the battery. So here, when it comes to reach, that repulsion will take place. So one electron pushed into the conductor. So like this, that electrons move from negative terminal to the positive terminal of the battery. Right? Field setup from positive terminal to negative terminal. So this positive terminal is said to be at a higher potential difference. Suppose it is at A terminal and it is at B terminal. So here it is taken to be VB. Then the potential difference will be calculated as the difference between the VA and the VB. So VA minus VB will give you potential difference. So like this, you are calculating the potential difference. Higher potential and lower potential energy gap. Potential is simply energy, right? So this we understood. Are you clear about this one? Are you clear about this one? Everything is good? Just go to quick reaction. Yes. So just concentrate on the diagrams to understand about these things, right? To understand about these things, just you can concentrate on the diagrams. Then only it will be easy for you. The next we are moving to the next topic, that is here simply in case of a battery. In case of a battery. So here in case of conductors, we are using, right, potential difference V, right? If it is by a battery, by the electrolyte, right, by the electrolyte, we can call that potential difference as here electromotive force, right? Electromotive force given as EMF, electromotive force. So here, what amount of force will act on the charges to move in opposite direction? So here chemical force always accelerating the positive charges, right? Once the charges are ready to move, then the collisions and attractions between the particles will take place. That will generate the field in it. So that field act on the electric charges to move opposite direction to the positive charges. Right? So these together working in a battery in opposite directions. Right? So that force we are here calling as that is electromotive force. Right? Electromotive force. So here simply electromotive force also nothing but potential. But by the electrolyte, it is said to be EMF. Right? So here, if it is connected to the conductor, water battery, what happens? That electrons are moving in a conductor through the conductor with a drift velocity. In this, they are losing their energy continuously and they will be accelerated by the positive terminal. They will be accelerated by the positive terminal. So this is simply applying the force on the charges. Applying the force on the charges. So here, so they are here negative ions, right? They are equal in amount. They are equal in amount as for the positive charges. Here they are moving simply from positive terminal to the negative terminal. Positive charges are negative terminal to the positive terminal. So always the electric field setup from positive to negative terminal. Then electrons are moving here negative terminal to the positive terminal. Electrons are moving from negative terminal to the positive terminal. That is opposite to the field direction. That is opposite to the field direction. Right? So the work done, right? The work done here in moving the charges, that electrolyte chemical force is doing something work. So what the chemical force does the work, what the chemical force does the work, that we can call it as here electromotive force. So electromotive force is nothing, the work on the unipositive charge, right? So W is given by F into S. So in case of a battery, we can take that distance between the metallic plates as a small d, right? Then here the force upon charges is Fc. So here Fc into d by q is positive. So Fc into d by q, that is here given as EMF. So EMF work measured in joules and the charge is measured in coulombs. This joule per coulomb named as here simply volts. Right? So EMF also measured in terms of volts. So what are the units of EMF? Volts. So the work done on the unipositive charge from to move from positive terminal to the negative terminal. Right? Unipositive charge from positive terminal to the negative terminal. Right? Then negative charge, it is from negative terminal to the positive terminal. Right? So like that you are defined. See here, positive terminal to negative terminal against the electric field. So once charge is started to move or it is set up to vibrate from their main position, it can generate electric field. Vibrating charges only generating the field. So that field is set up. Then once the field is set up, electric force will act on the charges. Completely opposite to the chemical force. Right? Just concentrate. It will be easy to understand. Okay. So here, okay, force is set up. It is started to move through a conductor or through a battery. Then the question is simply here, how we can measure the potential difference or EMF. Right? So here, simply to measure the potential difference or EMF, right? Potential difference we can use in case of conductors. EMF we can use in case of cells or batteries, right? So both are measured by the same device called voltmeter. Voltage is measured by voltmeter or potential difference or the EMF, nothing but same. So they are measured by the voltmeter here. That voltmeter always connected in a circuit, particularly in a parallel combination. Right? Always this device is connected in a circuit in parallel combination. So we can connect always in a parallel combination. Parallel combination is nothing, simple to understand. Here, if you are using a single wire to connect all the devices, that is called here series combination. If you are making alternate path, right? Making alternate path, that we can call it as here simply parallel combination, right? This is called a parallel combination. So here how we can connect in a circuit, that I will show you here only. Simple. Just you need to take a cell connecting wires. So suppose here battery is taken like this. So positive terminal, negative terminal. From the positive terminal, I am connecting a wire to the switch. Suppose here it is switch. Then from switch to the bulb here. Then bulb to cell. Right here in this, if you are connecting a ammeter, if you are connecting ammeter, ammeter always connected in series combination. So using this single path only, you are connecting that ammeter like this, right? In the same path, in the same path, you are connecting this ammeter. Then voltmeter in parallel combination. So here at the consumers resistors, right? There you are connecting voltmeter to measure the voltage through that, right? So this is parallel combination. This is series combination with the battery, right? So here it is only allowed in a single path. Here you made a junction, right? It will divide into different parts, right? So that you need to keep it in your mind. Okay. So this is about electromotive force. Any confusion? Just go for your quick reaction. Yes or no? Are you in doubt? Okay. Vikrant, Rohit, clear. Right. And now here we change the topic. So which charges are moving through a conductor? Negative charges or positive charges? Can anybody answer me? Through a conductor, what are the type of charges moving? Are they electrons or protons or both you are expecting? Which type of, what type of charges are moving? What type of charges are moving? No one answering. Here simply, it is from Rood and Lorentz theory. Positive charges are fixed throughout the conductor. That space we are named as lattice space. We named as lattice space, right? So there is no chance to move positive charges through a conductor. So what are the free charges available? Negative charges. In what direction they are moving? They are moving opposite to the electric field. That is from negative terminal to the positive terminal. Negative terminal to the positive terminal. Right. So here now we learned, right? Up to now we learned about two things mainly. What they are here, that is about electric currents, motion of charges only called as electric current. Simply the rate of charge flowing through a cross section, amount of charge passing through any cross section, that is given as I equal to Q by T or I is equals to N into Q by T. Any formula you can write. Here capital Q written, it is taken to be net charge. Small q is taken unit charge. N is number of charges. Right? So I equal to Q by N into, sorry, I equal to Q by T or N into Q by T. Then one more we learn. One more we learn. That is here potential difference. What is potential difference? The amount of work done, right, in moving the charge from left end to the right end in a conductor. So what amount of work you are doing to move that or to bring the charge from one end of the terminal to the other end of the terminal. That work done is called as potential difference. So here you got that relation is here. V is equals to W by Q, that equal to F into S. So Fe into L by Q. Right. So now, is there any relation between this potential difference and the current? Right. We learned two things, that is about electric current and potential difference. Now we are trying to understand the relation between the electric current and the potential difference. What happens if you change the potential difference? What happens to the current with varying potential difference? Right? So that we need to understand. So for that you are conducting simple activity using the batteries or cells. Battery, that is combination of cells. Combination of what? Cells. Right? Combination of cells only called as batteries. So how many batteries are required? As many as possible. Right? Minimum you need to take 5 observations. So 5 times you need to change the value of the potential difference. Right? So minimum 5 cells are needed. Right? That 5 cells having the equal potential difference, that is equal to 1.5 volts. That is equal to 1.5 volts. Clear? Right? So here for 5 values I am taken. Suppose if you want to take more measurements, you can take 10 cells also. So 10 observations you can make. Right? So eyes, many eyes. So why you are observing minimum 5 times to observe the changes. Right? So here always you are increasing the potential difference. What happens to the current with varying potential difference, increasing order of potential difference? Will it increases the current or decreases the current or no effect on the current? In 3 ways you need to think. Maybe the current value increase or that current value decrease or that current value remains same, equal. This you need to focus. So simple. Why you are conducting this activity? What happens if the potential difference increases through a circuit between the ends, right, of conductor? If you are increasing the potential difference, what happens to the current passing through the conductor? That you need to observe. So here you need to measure 2 things here. Then that one is here potential difference, right, and amount of current you are measuring. So to measure these things, what you require to measure the potential difference, you are required voltmeter, right? Then to measure the current, you are required ammeter. So 2 devices you are required. Then you need to make a circuit to connect all these electric components. Water, batteries, voltmeter, current. So you need to measure the current. So voltmeter, ammeter. The next to make a circuit, you require wires. Consumer is needed. That is here simply a resistor. That means a bulb, right? So bulb is needed to check your circuit working times. Then here you are dealing with the metals and non-metals, semi-metals. So metals, good conductors. Okay. So better to select 2, 3 materials made up of iron, copper, if possible, any other. Right? So I am taking iron spoke and a copper spoke having completely all the properties same, physical properties like a shape, size, volume, everything is same, right? So iron, copper, iron spoke, copper spoke. Then here you need to make a circuit, right? How we are making circuit? Simple electric circuit by taking a cell, right? Then choose its positive terminal, connect it with the wire piece, then just connect a switch here, from the switch to the bulb here, right? Here we are using LED bulb. You need to follow one thing here in connecting that LED bulb into a circuit. What is that? Here, simple. For a LED bulb, you are having two terminals, that long terminal and short terminal. Long terminal is connected to the positive terminal of the battery. Short terminal is connected to the negative terminal of the battery. That you need to verify. Right? So while you are connecting LED bulb, you need to check that long terminal and short terminal. Long terminal always connected to the battery positive terminal. Short terminal is connected to the negative terminal. This you have to see. Then connected. Verify. Is it working or not? So ammeter is connected in series combination. I need to connect the voltmeter. So for that, I am making a junction here to connect a voltmeter here, alternate path. So voltmeter is connected. So this is the circuit you need to prepare. Right? So minimum required things I am given, and I also given you circuit. Right? So make a gap here. Remove the battery. So remove the bulb here. Remove the bulb here. So here, if I remove the bulb, your circuit will be left with only these things. Right? Only these things. So here you have a gap here between, suppose, something P and Q. So this PQ is connected by once iron spoke. In next attempt, you may connect it with a copper spoke and then LED. Right? So once I am starting with iron spoke. Right? So here this gap is filled now using iron spoke. The gap left between P and Q will be connected by iron spoke. So look at that iron spoke now connected between the terminals P and Q. The gap is filled by iron spoke here. Okay. So straight. So iron spoke is connected. Then what to do? You have 2 meters. 2 meters. What they are? They are here ammeter and the voltmeter. So measure current and voltage. Measure current and voltage. Are you taking only single observation? No, 5 observations. So you need to note down that. So why to understand about the variation? So I am making a table for that. Notice the values, right? So how many attempts you are making? 5 attempts. So serial number 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. Then here I am measuring the voltage V. I am measuring the current I. So for the first value, voltage is given by only single cell, that is 1.5 here. So 1.5 volts. Then I am going to observe current value in the ammeter, right? So what is the current value here? Something I will get the value unknown. So I1. Then what to do? Increase the voltage. How you can increase the voltage? By adding one more cell into your circuit. So here add one more cell into the circuit. So now I am using here two cells. I am using here two cells. Suppose here I am showing that using two cells. So two cells are connected. So one is 1.5 and the other also having the same. So 1.5, 1.5, it will become 3 volts now. So voltage is taken 3 volts. Then read the ammeter, right? So note down that value. I don't know what the value you will get. So I am giving you blindly I2 value. I2 value is here. So you will read the ammeter, which reading unknown. So it may be 1.5, 2 amps, whatever it may be, 0.5, whatever it may be. So that I am giving as here I2 value, right? Then again, you need to increase the potential difference. So adding third shell into this, adding third shell. In which combination? Series combination again. So third shell is added. Then your potential difference will become 4.5 volts. Then note down the current by reading the ammeter here. So it will become I3 value. Next, increase voltage by adding one more cell, fourth cell. So that potential difference will become 6 volts. Then here note down the value, it will become I4. So here one more cell adding 7.5 it will be. Then the note down value is I5. So I got the values. I got the values. What it is given as here I1, I2, I3, I4, I5 respectively. I1, I2, I3, I4, I5 respectively for the potential differences V1, V2, V3, V4, V5. They are given as values here 1.5, 3.0, 4.5, 6.0 and 7.5 volts. Then you need to analyze these values. Analyze these values, voltage and current relation. So in what process, mathematical operation, you will understand the relation given as constant by taking the product or by taking the ratio or by taking a addition or by taking a subtraction, right? So addition subtraction will never give you the constant value. There is only possibility by taking the product or by taking the ratio. So here, if you take the product, will it give you constant value? No, sir. Suppose I am assuming here 1 and 2 for the I1 and I2. So what the product of V and I will give you? 1.5 into 1, 1 only. 3.0 into 2, it will give you 6. So it never give you constant value, right? It never give you constant value. So in this, you are identifying the relation between the voltage and the current will give you a constant, right? So voltage versus current. That means V1 by I1 equal to constant, V2 by I2 equal to constant, and V3 by I3 equal to constant, V4 by I4 equal to constant, V5 by I5 equal to constant. Then compare that constant values. So when we will say actually constant, if they are standing for the same value, if they are standing for the same value. So the ratio between voltage and current value always giving you same value. So from this, what I am able to say here that voltage and current ratio, always remaining constant, So V by I is equal to constant. If I remove that proportionality constant, I am able to produce a relation between the voltage and current is here V is proportional to I. V is proportional to I. With material iron spoke here. With the material iron spoke. Right? I made a observation. Voltage increased in a conductor. Automatically the current passing through the conductor increases. So that you are observing. So in the increasing order of potential difference, what happened? What happened? The amount of current also increased. So this we observed in the same order. In the same order. By the values, we can realize this one. Right? By the values, we can realize this one. By the voltage and the current values. So simply, you are able to give a relation between the voltage and the current is V is proportional to I, or V by I is equals to constant. So in which case I noticed this one? In case of iron spoke, right? In case of iron spoke, then I have a doubt. Only it is applicable for the iron spoke. What about copper? What about aluminum? What about silver? So like this, I need to verify. So in case of all metals, I noticed that voltage is proportional to current. Voltage is proportional to current. So voltage versus current ratio always constant in any metal. In any metal. So for all the metals, just we notice that voltage is proportional to current. Then what about in case of non-metals? Metals are good conductors, we know that, comparing with any other materials, right? Metals are the good conductors. Then what about non-metals? What about semi-metals or metalloids, right? So this also we need to verify. Semi-metals and non-metals, right? So non-metals, solids and dry condition, we know already they are acting like what? Insulators. That means they are not allowing the current through them. They are not allowing the current through them. So simply you are able to decide V is not giving you a constant ratio by the current. So V by I is not equal to constant in case of non-metals. They are not giving you constant value. So in case of insulators, then what about in case of semi-metals? Their properties varied in between or lie or intermediate between metals and non-metals. Like what on the staircase, we observed some metals in modern periodic table, like silicon, germanium, arsenic, like aluminum, so many are there. Right? So these are what semi-metals. Are these semi-metals are conducting or not? Then the ratio versus voltage and current giving you constant or not. This you need to verify. So in this also we can observe that not constant. So I say semi-metal, what we are using? LED bulb. So made up of semi-metals, right? Like silicon, germanium, right? Diodes, simply light emitting diode. Diodes are made up of silicon and germanium, right? So that LED bulb we are using to connect the gap left A and Q. So if you connect that, again you are repeating the same process. Voltage starting with 1.5, then changing it 3.0, changing as 4.5, changing as 6.0, then changing as 7.5. Every time you are increasing one cell, adding in series combination. Then for this value, you need to measure the current values I1, I2, I3, I4, I5. Right? Maybe they are giving the same value or the different value, we don't know. But you need to verify V by I ratio in each case. That means V1 by I1, V2 by I2, I so on, V5 by I5. So in each case, observe the value given by them are the same or they are standing for the different values. If they are standing for the different values, what you are able to generalize? V by I ratio not equal to constant. So you are unable to give you this relation between voltage and current. There is no proper relation between them, right? So here V is proportional to I, applicable to only metals, only metals that we observed, right? So this is verified by Ohm, scientist Ohm. So this law is given as Ohm's law. This law is given as Ohm's law. So how do you define Ohm's law? Voltage is directly proportional to the current. When the voltage increases, the amount of current passing through a conductor also increases. Is there any confusion in this lab activity? Just use your quick reaction how to conduct this activity. Have you got an idea? Have you got an idea? Yes. Yes. Right. So just we have few more discussion related to this same topic, Ohm's law verification. Right. Then join immediately using the same method.